Okay, today we're going to do 4.1 and 4.2, which is exponential functions and their applications. And so an exponential function, this is the definition for that. So a is greater than 0, a is not equal to 1. It's defined by f of x equals a to the x. So the x is your exponent. That's what makes it an exponential function. So you're going to be asked to classify some linear, exponential, and quadratic functions. Like I told you, if you have f of x equals 3 to the x minus 7. If you see that x in an exponent, then that's going to be an exponential function. Okay. If you have f of x equals 4x plus 2, this is in the y equals mx plus b format. You should recognize that one, which again, that gives you a line. And so that means that it's a linear function. So we have a linear function when our exponent is 1 on the x. We have an exponential function if the x is in the exponent. And then we have a quadratic, which we've already talked about quadratics, but we have a quadratic when we have an x squared term. So if we just have 3x squared, this is a quadratic. Now keep in mind that a quadratic could also be written as f of x equals 3x squared plus 7x plus 5, something along those lines. But the squared is what screams that it's a quadratic. And when you see quadratic, you think four terms. If you remember, you had FOIL and the outer and the inner terms combined together. That's where they get the word quadratic from, is because they're officially four individual terms, but two of them are the same. All right. Another thing that you'll have to do is you will have to graph exponentials. When you graph exponentials, you're going to get a curve like that, or a curve, that type of curve one way or the other. So the best part is to try and find out where this curve is at. Otherwise, you might think it's straight line and stuff. To do that, you're going to take your exponent, in this case it's x, and you're going to set it equal to 0 and solve. And once you do, you find out what that x value is, where that curve is the best. So then after that, you're going to go ahead and set yourself up a table. And so you're going to put that right in the center, because that's where the center of the curve is at. Then you pick a number below and a number above. So it's kind of like your absolute value graphs and your parabola graphs, your quadratic graphs. So I'm going to pick -1 and I'm going to pick +1. If you pick numbers just to one side, it might show that it looks like a straight line, and we don't want that. So we got to pick one on each side of that. So when we plug it in, we've got 4 to the -1 power. This is where your rules for your exponents are going to come out. And so when you have a negative on an exponent, then that means that you move it to the opposite location. So this is going to turn into 1/4. And then we do 4 to the 0 power. And keep in mind, anything to the 0 power is 1. And then 4 to the first power, which ends up being 4. So now we go and graph. Again, I will have the XY coordinate system on the test for you, so you don't have to worry about graphing that. All right, so we got -1 and 1/4, 1/4, not -1/4. So that's there. Then we have 0, 1, which is right there. And then we have 1, 4. And if you can see that curve coming out. So what you do, you start beyond the furthest point. So that would be this point right up here. 1, 4, come down. And then when you hit that last point, I want you to kind of flatten out. Okay. The reason for that is because once you flatten it out, this part right underneath creates what's called an asymptote. This is a horizontal asymptote. And what that tells you is that function is undefined at that value. So it's either going to be right above or right below your flat line that you did. And it's not going to be above in this case because it would go through that graph. Okay. So therefore, it's got to go under it. And it actually ends up, in this case, being the x-axis. Now, just to kind of clue you in, when you're doing my math lab, you're going to click on a point for the graph. You're going to click on your exponential graph, okay, this curve, and then it's going to bring up this table. And down at the bottom of the table, it's going to say base, and there will be an E in here. You will have to change that E to whatever your base is. So if we were graphing this one on my math lab, we would change that base to a 4. Okay, so make sure that you change the base when you're working through those problems on my math lab. If you have any problems with my math lab, because this is one of the ones where they're really picky about it, don't hesitate to email me through my math lab and let me know, what issue is going on, or just, regular email. It'd be better to email me through my math lab though, so I can see what's going on. The other thing, my math lab does not have you graph the horizontal asymptote. You will need to graph that on the tests. All right, so let's look at this one. Okay, again, we're going to take our exponent. So we're going to do 4 minus x. We're going to set it equal to 0. That's an equal to, so equal to 0. And we're going to solve this. So we're going to subtract 4. So that's negative x equals negative 4, which means x equals positive 4. All right, so now we go set up our table. We're going to put that 4 right in the center. We're going to pick a number below and a number above. So when we plug in, we're going to have 1/3 to the 4 minus 3. Okay, so that's 1/3 to the first power, which is 1/3. Then we have 1/3 to the 4 minus 4, which is 1/3 to the 0 power. And again, anything to the 0 power is equal to 1. And then we have 1/3 to the 4 minus 5 power, which is 1/3 to the negative 1, which again, that flips over the fraction. So that's going to give us just 3. All right. Now we go do our graph. Okay, so I've got 3 and 1/3. So there's that. I've got 4 and 1, and then 5 and 3. And like I said, there's always going to be one that's further away than the other two. So that's how you know where you're going to start. So you're going to start beyond the furthest away part. And when you hit that last point, just flatten out. It doesn't really flatten out. It gets closer and closer and closer to that asymptote. And so in this case, again, the x-axis happens to be our asymptote. Label it HA. All right. Will it be the x-axis every time? It just depends on what your problem is. But again, you're looking above and below that flat line. And some of you might say, well, why isn't it this part right here? Because it's going to cut through my graph. See, it cuts through my graph right over here at the 0.41. We don't want it cutting through our graph. So therefore, that cannot be the asymptote. So the asymptote has to be right below. And again, it's the next line below or the next line above when doing that problem. All right. And like I said, with my math lab, you just click on it, select the option for exponential, and then you make sure to change that base. All right. And that's pretty much it for 4.1. 4.2 goes a little bit deeper. We got exponential growth function, y sub 0 e to the kt. The one that you'll be using the most will be this y sub 0 b to the t. And you're going to need to know that for the test. You're not going to be giving that to you. All right, where b is a constant. And you will see that as we go through our examples and stuff. But the y sub 0 e to the kt, in case you've never heard about e is a number that is kind of like pi. It's 2.71828, and then it goes on forever, just like pi. That's what this e is for the y sub 0 e to the kt. But like I said, I think they've taken most of those out for you. They may have you evaluate some. Just use the E button in your calculator. That's the best way to do that. All right. They will ask you to find the exponential growth function. When they're asking you to find the exponential growth function, then you're going to use this f of t y sub 0 b to the t. So we will use that one for these examples in 4.2. All right, the annual amount of energy produced in a country from dry natural gas in trillion cubic feet can be approximated by the following function, where T equals 10 corresponds to the year 2010. So we need to find the amount of dry natural gas produced in 2022. All right, so first of all, before we can use our function G of T equals 16.9 times 1.034 to the T. Before we can do that, we've got to find out what T is. Well, we know T equals 10 corresponds to 2010. So we've got to find out the T that corresponds to 2022. Well, if you notice, it's the last two digits of the year. So this is going to be T equals 22. So we now can go find out our function. You could say G of 22 or just G equals 16.9 times 1.034 to the 22nd power. This is not something that you're going to be able to calculate in your head. You will need your calculator for it. And so we'll have G is equal to, and y'all, I keep forgetting my calculator. All right, let's see. Okay, so I've got 16.9 times 1.034 raised to the 22nd power. All right, so this is going to be 35.265. Go 3 decimal places for me. I don't know what my math lab is. Okay, so it's 35.265 trillion cubic feet. Okay. All right, because again, we're looking for the amount of dry natural gas energy. And so that amount of energy, according to the problem, is in trillion cubic feet. T is your number of years. So realize what each one is representing. All right, so this ends up being your answer. All right, so it says if the model continues to be accurate, project the amount of dry natural gas energy produced in 2025. So again, we're going to use the G of T equals 16.9 times 1.034 to the T. And we want to know for 2025. Okay. All right, so this 2025 is going to give us T equals 25 because we already determined that it's the last 2 digits in this case. So T equals 25. We're going to plug that in. So we'll have G is 16.9 times 1.034 raised to the 25th power. And so if we do the 25th power, then if the model remains accurate, that's going to be 38.985 trillion cubic feet. As long as I got my units right. Yep. Okay. So that's a pretty much plug in and chug if they give you that T. If they don't give you that T, then you've got a little bit more work to do, and I'll show you what we're going to do with those. But in the start, they start giving you the T, and so you just plug it in. And like I said, when you get to this point here, you're going to have to use your calculator. Be sure that you show me, like this part 16.9 times 1.034 raised to the 25th power. Show me what you are plugging into your calculator. And before you just give me the answer. If I don't see any work, then I could mark things wrong. So I want to make sure that I see your work on your test. No work, no credit. Okay, so Um, suppose the total value for cryptocurrency in billions of dollars was 105 in January 2020 and 746 in January 2021. Find an exponential function of the form f of t equals y sub 0 b to the t model um, to model these data in t equals months. Okay, so t is months, where t equals 0 corresponds to January 2020. So we're using that f of t y sub 0 b to the t like I told you up above. All right, the best thing to do on this is to write down your information. So we know that we have 105 billions of dollars, and I'm ignoring the billions of dollars right now. We're using this for January 2020, and we have 746 billions of dollars for January 2021. Okay. All right. So in the question, it actually tells us that t equals 0 corresponds to January 2020. So they will always tell you what t equals 0 corresponds to. You will not have to guess that. All right. So the question is, what is T for January 2021? Well, because T is in months, January 2021 is going to be 12. Really, it's 13 months counting January 2020, but because January 2020 is T equals 0, we don't count January 2020. So we count all the other months from January 2020 up to January 2021. So T is equal to 12. Now, again, we're doing the general model for f of t equals y sub 0 b to the t. The things we want to fill in for on our general model are y sub 0 and b only. F of t and t we do not fill in. Well, y sub 0 is going to be very easy to find because they will always tell you what t equals 0 corresponds to. So t equals 0 is going to give us our y sub 0, and our y sub 0 in this case is going to be 105. All right, the months January 2020, that helps us to figure out our t. All right, so the question is, how do we find out the b? Because the b is the harder one to find. And so we use this other information. So this 746 is actually our f of 12. So when we go to plug in our information, our f of t is going to be 746, because again, we're using f of 12. And that's going to be equal to our y sub 0, which is 105. B, we don't know, to the 12th power. These two numbers will always correspond. So 12, t equals 12, corresponds to 746. So now we need to solve this for b. So we're going to divide both sides by 105. Okay, don't plug it in your calculator yet. We'll do it all at once. It'll be a whole lot better. All right, so we've got 746 divided by 105 is equal to b to the 12th. Now, back in algebra, you learned that the square root of x is equal to the same as x to the 1/2 power. The reason why we use this type of situation is because some calculators won't do like a 12th root or a 50th root or a 86th root. And so that's where the fraction comes into play. So that's what we're going to do here. We're actually going to take the 12th root of both sides, but the way we're going to write it, we're going to write 746 divided by 105 to the 1 over 12th power is equal to b. Now, I normally put parentheses around that exponent. The reason being because when you plug this into your calculator, you're going to plug it in as parentheses 746 divided by 105, close parenthesis, and then this caret button. This will show up. You'll either have the caret button, or actually, I think on your calculators, it's y to the x. So you hit that y to the x and it puts that in there. And then you do parenthesis 1 divided by 12. And again, you got to make sure you have that second set of parentheses. And then hit enter. And so when you do that, you end up with 1.1775 for your b. Now, we needed the b and we needed the y sub 0 for a general model that we mentioned up here. We are not using the 746 and the 12 in our general model. So the way we write our model is f of t equals 105 times 1.1775 to the t. And I like putting parentheses around my b just to kind of make it distinguished. If you don't, then you need to show the multiplication symbol. But again, that can get a little confusing with our decimals and stuff. So it's actually a little bit better to use parentheses. All right. And so this ends up being your general model. And the more you do of these, the easier they do get. All right. So part B of this says, by experimenting with different values, estimate the first full month. Again, this is an estimate that they're asking for. My math lab is going to want exact, so I'll show you how to do exact. But this is an estimate. So if I ask you for an estimate, I want you to approximate it. Most likely, I will not ask for an estimate. I will actually ask for what is the first full month. So you'll have to find it exactly. So I'm going to show you how to find it exactly on here. All right, so we have our general function, f of t equals 105 times 1.1775 to the t from up above. And I'm just pulling that back in. All right, it says estimate the first full month. Keep in mind, t is your months in which the value of the cryptocurrency exceeded 389 billion. So the 389 billion is our f of t in this case. So we're going to have 389 equals 105 times 1.1775 to the t power. All right, so now we solve this out. So the first thing we do is we divide off the 105. We can't take the 105 times the decimal because of the exponent. So we have to divide it off. So we have 389 divided by 105 is equal to 1.1775 to the t power. Okay. Now, how do we get the t out of the exponent? Well, we can't divide it. It's not a multiply. It's an exponent. So this goes back to college algebra where you had to put logs back on. So we would have the natural log of 389 divided by 105. And you can use log if you want to. I use natural log just because it's easier to write. 1.1775 to the t. Well, one of the things you learned when you put logs on, your exponent can come down in front of your logs and be multiplied. That was one of the properties. And so that's the case that's going to happen here. So we'll have the natural log, that's ln, of 389 divided by 105 equals t times the natural log of 1.1775. And now, because this is multiplied on the right-hand side, we can divide off that natural log. So this will be the natural log of 389 divided by 105 all over the natural log of 1.1775 is equal to our t. So when we plug that into our calculator, again, watch those parentheses, you end up with 8.0151. Okay, I know up above it said 3 decimal places, probably be best to go 4 decimal places just because of my math lab. All right, so we know that t equals 0 corresponds to January 2020. So if we count this out, 1 is February, 2 is March, and we continue on. 8 is actually September. However, this is asking for the first full month in which the value exceeds 389 billion. It will exceed 389 billion in September, but not the full month of September. So in this case, our answer is going to be October of 2020. That's the first full month that it has exceeded 389 billion. So be sure to watch your questions and stuff and what they're asking so that you answer the correct way. If you have any questions, don't hesitate to email me. Again, through my math lab would probably be best. Okay. And or come by and see me. Have a great day.